Why gears fail. Gear performance. Understanding the challenges gears face in cold conditions. Gears are vital components in numerous mechanical systems, especially in winter conditions. The challenges posed by low temperatures, moisture, and environmental factors can significantly impact gear performance and reliability. Understanding these challenges is crucial for engineers and maintenance professionals aiming to enhance gear durability and operational efficiency in cold climates. Environmental factors impacting gears. Low temperatures. Brittleness and hardness changes in materials. Snow contaminants. Abrasive particles increasing wear on gears. Moisture. Frost buildup causing mechanical issues. Lubrication issues. Thicker lubricants causing friction problems. Winter environmental factors, thermal cycling effects. Thermal cycling, temperature fluctuations can significantly weaken gear integrity. Common winter gear failures. Wear mechanisms. Abrasive wear increases due to cold temperatures. Lubrication failure. Insufficient lubrication leads to increased friction. Fatigue cracks. Cracks form from repeated mechanical stress. Corrosion. Moisture accelerates corrosion in cold conditions. Misalignment and seizure in gears. Gear misalignment. Misalignment leads to increased wear and potential seizure. Root causes. Material behavior. Cold temperatures reduce ductility and increase brittleness. Low temperatures increase viscosity, affecting performance. Lubricant behavior. Frozen lubrication leads to micro-welding and wear. Surface interactions. Root causes. Environmental ingress in gears. Water ingress. Environmental moisture intrusion compromises gear performance reliability. Utilizing low-temperature viscosity lubricants. Prevention strategies for gear reliability. Material selection. Choosing alloys suitable for low temperatures. Sealing and coatings. Preventing moisture ingress for gear protection. Lubricant selection. Utilizing low-temperature viscosity lubricants. Design modifications. Adjusting clearances for thermal expansion. Maintenance. Best practices for gears. Gear inspection. Regular inspections ensure optimal performance and reliability. Clearance adjustments for gear reliability. Gear clearance. Proper adjustments ensure optimal engagement and performance under load. Case studies. Successful adaptations. Innovative design reduced gear failures significantly. Maintenance strategies. Regular inspections ensure optimal gear performance. Conclusion. Overview of key challenges in gear performance during winter conditions. The challenges of winter significantly impact gear reliability, leading to various failure mechanisms. Understanding the interactions of low temperatures, moisture, and environmental stresses is essential for professionals to implement effective strategies. This integrated approach ensures operational efficiency and longevity of gear systems in cold climates. Integrated approach to gear reliability. Integrated management. Combining material, lubrication, design, and maintenance ensures reliability. Final. Recommendations for winter gear reliability. Material optimization. Select cold-resistant alloys for enhanced performance and durability.